Good morning, Roslyn Bulldogs. Today we are going to read a story about Curiosity, the Mars Rover, and this book was written by Marcus Modem. And I happen to know that we have this book in the Roslyn Library, so if you want to check this out and read it yourself, you can request it from Mrs. Lang. And they probably have it at a couple other libraries as well. And this story is about the rover sent to Mars to do some exploration. So we're going to learn a little bit about this rover today. And then I've got some other places you can look for more information about the Mars rovers. And make sure you stay tuned to the end of the video for a special STEM challenge if you're up for it. Curiosity, the Story of a Mars Rover by Marcus Modem. Wherever you are in the world right now, I'm in a very long way away. I'm not even on the same planet as you. I'm a Mars rover. A rover is a moving robot, built to explore far-off places, places too far or dangerous for humans to visit. How did I get here? Why was I sent? This is my story. Humans have always wondered about Earth and its place in the universe. Although scientists have made great discoveries and explained some of the mysteries of space, the planets hold their secrets well. Many questions remain unanswered. Of these, one question intrigues humans above all others. Is there anybody else out there? Scientists decided that the best place to look for other life was on one of our closest neighboring planets. Mars, the red planet. In addition to being one of our two closest neighboring planets, Mars is the planet in our solar system that's most similar to Earth. Scientists think that in the past, Mars may have had environments similar to ones on Earth today. Mars is covered in red dust now, but there is evidence that millions of years ago, the planet may have had lakes, flowing rivers, and even great oceans. Why does this matter? Because on Earth, water is a necessity for life. However, there is one problem. The trip to Mars in a spacecraft can be over 350 million miles long. That's 350 million miles, 560 million kilometers. A distance much, much farther than any human has ever traveled in space. Even with our modern technology, we don't have a practical way to get humans to Mars. The journey would take at least 6 months, or to get them back. Humans have been able to explore closer to home. On July 20th, 1969, Apollo 11 landed on the moon. Astronaut Neil Armstrong took one famous step and became the first person to set foot there. For the few hours he and Buzz Aldrin walked on its surface, people could look up at the moon and know that someone might be looking back at them. Mars is about 200 times farther from Earth than the moon, a journey that is currently very difficult for humans to undertake. The red planet is also an inhospitable environment. But what if it were possible to send an explorer who didn't need food, water, or oxygen? That's where I come in. Scientists at NASA, the National Aeronautics and Space Administration, came up with the idea to send robots to Mars in humans' place. The robots would need to be able to move over rough terrain with all the equipment needed to collect data and samples. So the scientists began to design rovers like me. You can see the Apollo astronaut and all of the things that went into his suit, and an early Mars mission Mars rover. They had solar panels to power them, a camera to take pictures and videos, and wheels that were able to drive over rough terrain. And there's Mars. The project to build and design Mars rovers was, and still is, based at the Jet Propulsion Laboratory near Los Angeles, California. I needed to be larger and more advanced than any of the rovers NASA had built before. Previous successful rovers had taken photos of Mars, giving NASA never-before-seen images. Other missions were orbiters and flybys, flying around or past Mars to gather information without even landing on the planet. By 2007, 39 missions to the Red Planet had been launched, and over half had ended in failure. Some of these earlier missions had become lost in space, while others crashed into Mars, never to be heard from again. The lab where I was built had to be kept as clean as possible. Everyone had to wear white coveralls, which were nicknamed bunny suits. These suits stopped dust and germs from spreading to me and my equipment. The suits covered a person from head to toe, so no hair, skin, or other human dust could be shed into the clean room. The air shower blasted away dust, hair, and skin from the coveralls before people entered. The static electricity can harm equipment. This cord helped team members from giving off static shock by transferring any static charges to the floor. And filters were used to remove as much dust in the lab's air as possible. The team didn't want to think they had discovered tiny forms of life on Mars, only to realize that it was just Earth bacteria that he had brought with him. Scientists recreated Martian environments to test rooms at the lab so they could check that I was prepared. My wheel system was designed to keep all 6 of my wheels in contact with the ground at all times, on any terrain I might encounter. Entirely new technologies had to be invented for my mission. I needed to be able to carry a lot of equipment to test what I found on Mars, my own portable laboratory. To give the mission the best chance of being successful, years of testing were needed to make sure everything would work correctly the first time. After all, if something were to go wrong on Mars, no one could come and fix me. There was a weather station to record temperatures and wind speeds, an antenna used to communicate with the team on Earth, camera pointing downwards to film the ground to approach landing, and hazard cameras or HazCams to spot dangerous terrain. NASA ran a competition for members of the public to choose a name for me. Some of the names considered were Adventure, Journey, Pursuit, Vision, and Wonder. The winning entry was submitted by Clara Ma, who is a 6th grader from Kansas. The name she picked for me was Curiosity. Just like you, I have a shoulder, elbow, and wrist, so I can be flexible as possible. My body carries the onboard chemistry lab where I run all my science experiments. This is my battery. It's nuclear powered. The plutonium in here will power me for years. My robotic hand has many tools, including a drill and a brush to probe the surface of Mars. These wheel treads leave marks that help me judge how far I've moved. And then I was ready to fly to Mars. It was best to launch eastward and close to the equator to get as much energy from Earth's spin as possible. This also meant it was safest to launch where the ocean was to the east, just in case something went wrong. So I had to be taken to Florida to begin my space mission. I boarded a carrier plane and flew from Los Angeles to the Kennedy Space Center. The rocket that would take me into space was waiting for me in Florida. The Atlas V rocket is around 200 feet or 61 meters tall, the height of a 19-story building. and it is almost all rocket fuel. This is because it needs to be powerful enough to launch whatever it is carrying, known as its payload, into space. The Atlas V is known as an expendable launch vehicle, which means its parts can be used only once. I was placed inside the nose cone at the very top. The cone is like a shield that protects the rest of the rocket as it breaks through the Earth's atmosphere. My launch date was chosen carefully so that I had the best chance at a successful launch and the shortest trip possible. Because planets orbit the sun at different speeds and distances, sometimes they are far apart and other times they are much closer together. Every few years, Earth and Mars are lined up so they are relatively close, allowing missions to reach Mars more quickly and using less fuel. If we had missed the opportunity, the mission would have been delayed for years. Launch day, November 26th, 2011. Arrived. I was ready to fly to Mars. In the control room, the team ran through the final checks. At last, the rocket was ready for countdown. 5, 4, 3, 2, 1. Liftoff! The first part of my journey was breaking through the Earth's atmosphere and reaching space. Once Atlas V's various boosters had done their job of getting the rocket into space, they broke off and fell safely into the ocean. These 4 boosters helped the main rocket escape Earth's gravity, then fell back to Earth once they were used up. This is the Common Core booster and its engine. It's about 107 feet long. Its fuel tanks were filled with kerosene and liquid oxygen. Once the rocket had carried me safely into space, the nose cone protecting me broke off and fell back towards Earth. Then the Common Core booster detached. Next, a second smaller engine burned its fuel to launch me out of Earth's orbit. 40 minutes after liftoff, that engine detached and I was heading for Mars. I made the rest of the journey in this protective shell called the module. The module used its star scanner and sun sensor to guide itself. Thrusters on the outside of the module could change its direction when necessary. They were the only part of the rocket that made the long journey to Mars with me. After 253 days hurtling through space, I finally arrived near Mars, traveling 13,000 miles per hour. Next would be the trickiest part of my entire journey, landing safely. No rover or space mission had ever tried the type of landing I was programmed for. It would take 7 minutes from the time I penetrated the atmosphere around Mars until I landed on the surface. The team at NASA called it 7 minutes of terror. If I had been landing on Earth, the atmosphere would have slowed down my entry, but Mars had much less atmosphere than our home planet. So as soon as I entered the atmosphere, a huge parachute opened, slowing me to about 200 miles per hour. I was still moving too fast, so I dropped out of the back shell. For a few seconds, I was free falling to the ground. Suddenly, the powered descent vehicle, which was holding me, fired 8 rockets, slowing me down almost completely. Then I was ready to be lowered to the surface on the cables, known as the sky crane maneuver. Once the descent vehicle detected slack in the cables, it knew I must be on the surface of Mars and released the cables. I had made it. As soon as I was safely on the surface, I sent a message to my NASA team, letting them know that I had landed. Because of the huge distance between Mars and Earth, the message took 15 minutes to get back to Earth. It was a tense time in the control room as everyone waited. Then the words everyone wanted to hear were read out. Touchdown confirmed. We're safe on Mars. Look at that. They broadcasted in New York City. It wasn't just the NASA team who had been watching my landing. All around the world, people tuned in to see if I had arrived safely after my long journey. Crowds gathered in New York's Times Square to watch on a giant screen. It was exciting but scary time. After all, if just one thing had gone wrong, all contact between me and the team back on Earth would have been lost. When they heard I'd landed, some people cheered. Others breathed huge sighs of relief. The next thing I did on Mars was send images of myself back to NASA to make sure I hadn't been damaged. The site had carefully selected by scientists as a place likely to have evidence of water. Now it was time to start looking. Since 2012, I have been exploring Mars. The NASA team looks through my 17 cameras and chooses potential spots on the surface that may have evidence of life. Once something is identified, I move towards it. I can move more than 600 feet per day. NASA also wants to understand how Mars was formed and how it has changed over time. The deeper I deep, the more information I can gather. I drill into rocks and scoop up material. I then test it on my onboard laboratory. Gradually, by piecing together information from different locations, NASA hopes to build a picture of the planet's past and perhaps discover why Mars changed from being a warm planet with water to the cold, dry planet it is today. Takes photos from his navigation and hazard cameras, uses the lasers to find out what they're made of, and drills holes into the surface. There are many questions still to be answered. What was Mars like long ago? How suitable was it for life? Did it once support any life forms? The tests I carry out will provide as many answers as possible. Most likely, the discoveries I make will lead to more questions. With space exploration, questions can be just as exciting as answers. Thanks to the curiosity of explorers, Neil Armstrong's footprints are on the moon. Now my wheel tracks are being left on another planet. Perhaps one day soon, footprints from the next generation of explorers will leave their marks here as well. Curiosity is the passion that drives us through our everyday lives. We have become explorers and scientists with our need to ask questions and to wonder. We will never know everything there is to know, but with our burning curiosity, we have learned so much. And that's the end of our book. Curiosity, the story of a Mars rover.
Good morning! Reporting live from the Barrington newsroom, this is your news anchor, Mrs. Nelson. You may soon know more about Mars and the future of human exploration of Mars. All thanks to the Mars 2020 Perseverance rover. That's right. Perseverance is on its way to Mars right now as we speak. The Mars 2020 mission launched on July 30th, 2020, but not before a suitable name was chosen for the rover.
NASA's newest rover is gearing up for its journey to Mars. We've been building the rover and getting it ready for launch, and kids across the country have played a big part too. We asked for your help to name the rover, and you answered the call. 28,000 kids sent in their essays with their best ideas. 4,700 judges helped narrow them down, and the world weighed in on their favorites too. Thanks to you, we now have a name. Perseverance.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We're always curious and seek opportunity. We have the spirit and insight to explore the moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we missed the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. the human race will always persevere into the future.
That name is going to live on Mars forever because it's going to be etched on the rover's robotic arm right there. The rover's mission is to seek signs of ancient life, collect rock samples for future retrieval, and to pave the way for human exploration of Mars someday. It's going to be a very exciting mission, and perseverance is going to be crucial to it all.
Thanks to all who helped us get here. Be sure to follow the journey of perseverance as it explores the red planet.
Thank you, Becca. That is exactly what we will be doing. We will be following Perseverance on its journey to Mars. Here I am, traveling with Perseverance on our way to the red planet. So, folks, why did we want to go to the red planet?
When you go to another planet,
let's take
there's
a
just
look.
so much potential for making brand new discoveries.
I'm actually putting something together that's flying to Mars.
One way or another, you're going to be on the ground in 7 minutes. We want it to be there safely.
My name is Heather Bottom, and I'm helping prepare the spacecraft that will fly our next Mars rover to the Martian surface.
My name is Diana Trujillo, and I work with robotic arms to collect samples on Mars.
I'm Al Chen, and I lead the landing team for Mars 2020.
My name is Michelle Tommy Colizzi.
My name is Mujige Stricker.
My name is Eric Agadan.
My name is Katie Stack Morgan,
And I'm helping to protect the next Mars rover.
Mars 2020 will be seeking signs of ancient life in the rock record of Mars.
What we're trying to do is to rove around the surface of this unknown planet.
Collect samples
Process the tubes as they come back.
To look for things that we call biosignatures.
so that eventually we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
But also, where could it be preserved for 4 more billion years for us to find it?
Before the rover actually flies, you have to make sure that everything works properly with the flight software and the hardware.
And we hit the atmosphere going, 12, 13,000 miles per hour.
After the journey through space, through the vacuum.
We try to test all of our hardware to the environments that we would see.
So that's where a lot of the testing happens behind me.
We spend lots and lots of hours here testing everything.
It gets put in an oven, it gets put in various chambers and clean rooms.
So what we can see over here is the stacked spacecraft.
The robotic arm is actually right behind me.
This is the place where the magic happens.
This is the Mars Yard, and this is where our rovers practice driving over rocky terrain.
There are hundreds of people that have to come together and build a spacecraft. You kind of have to put those different pieces together and make sure that those pieces all are going to work.
And I feel like such a lucky person to be working on this.
Everything that you're touching, all this hard work that you're putting in the long hours.
20 years, the children will be reading this in their science book.
It feels great.
Wow. Thank you, NASA. I, for one, learned a lot about Perseverance. In a nutshell, folks, Perseverance was developed to explore a geologically diverse atmosphere, explore ancient habituality, gather rocks and soil samples, and demonstrate technology for future robotic and human exploration. Back to you in the newsroom. Well, Barrington students, you've learned a lot about Perseverance, and now we need your help. NASA wants you to design the next rover, the 2030 rover. What special features will it have? What will it be able to do on Mars? How will it help NASA scientists and engineers? Draw out your rover and label it. Don't forget to name your rover, too. And of course, share it with your STEM teachers.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
You can find these books on Epic. Just search by Mars Rover, and they should come up for you to read.